Okay.
Yeah, I think that we can start. Okay, so good morning, everybody, and welcome to today's webinar, Overcoming Data Scarcity in Low Resource Languages. My name is Tomáš Kolárik, and I'll be moderating today's session on behalf of the National Competence Centers for HPC of Slovakia and Italy. Our speaker today is Marek Dobeš, presenting a case study on supporting Slovak as a low-resource language in large language model development. The talk will last around 45 minutes, followed by a Q&A session. Feel free to post your questions in the chat section, or otherwise you can ask your questions directly to the speaker after the presentation. Dr. Dobeš, the floor is yours.
Thank you very much for the introduction. Hello, everyone. I'm glad to be here and to share our experience with creating new data for Slovak LLMs. Well, our presentation is titled "Overcoming Data Scarcity in Low-Resource Languages," and I do this research together with my colleagues Radovan Garabik and Peter Bednar. So, first things first, we would like to thank the support from the Center of Operations of Slovak Academy of Sciences, which enabled us to use Leonardo supercomputer in Italy and Gemini supercomputer in Slovakia for this research. So let us start. We all encountered the great AI revolution, which brought us the large language models. And soon it became clear that the success of LLMs is based on the amount of data that you can train the models on. And of course, the languages with more speakers and more digitized data were favored in this respect. So naturally, the English-speaking models are the norm now. However, as the field developed, more and more national languages were added, more LLMs were created, and in our team we try to overcome the low resources in Slovak digitized text by employing several techniques. And we can say that really using these techniques, there may be no more low resource languages as we will see. Okay, so what are the main sources that you can get the data in national languages to train the LLMs? First, there are digitized resources in national languages, mostly found in libraries or research centers, and of course on the internet. Then the second technique to get the data are the LLM translations from other languages. When you prompt a model like a DeepSeek or GPT, who are capable of producing quality Slovak text, translate this to Slovak, they are capable of creating the quality Slovak text from books or text in English or practically any other language. Third, you can use LLMs to generate new content from a common database into national language, as those LLMs are trained on vast amounts of data and they are capable of creating the text in Slovak. So you can use them to generate the new data in any national language. And fourth, you can use LLMs for synthetic augmentation from data either in a national language or any other language. When you provide the LLM with a text and ask it to write a summary or expand the text, and thus you can get a new material as well. So there are new avenues you can take to extend the text base for any national language. Okay, what we do in our team. Our first model that we produced was Mistral with 7 billion parameters, pre-trained on Slovak data on approximately 5 GB of Aronia web corpus data. And this model is already freely available on Hugging Face. You can deploy it. And we were quite satisfied that with this amount of data we got quite quality results. Here are some examples. This is the original Mistral 7B model without any pre-training. This model had some rudimentary knowledge of Slovak, but really very rudimentary. You can see an example here when practically all the text that it produced in Slovak was full of grammar and stylistic errors. So after our pre-training, we got the model that is capable of producing almost flawless Slovak text without any errors. So in this model, we focused on the grammar and production of quality Slovak language. We didn't focus so much on the facts and on the content that it should be able to produce. So that was our first step to produce a model that can speak and can produce Slovak. Okay, so this model was trained. It took us about 10,000 GPU hours on Leonardo and Gemini computers, and it's already available on the internet. Okay, what are we working on now? Is we try to deal with the problem that when you translate text using a LLM into Slovak, with exception of really large models like DeepSeek or GPT, their Slovak is not very good. If you take LLaMA or Gwen or any of those models, the Slovak grammar and style is really not correct. So we tried to address this problem so that if you get a translated text, either by Google Translate or by any of those LLMs, we would like to have this text in a good Slovak. So what we did is we translated and back translated a database of data of Slovak texts, which were proofread by a major publishing company in Slovakia. And using translation and back translation, we got a new Slovak text, which was of low quality because of translation from English. And we are trying to fine-tune the Mistral Instruct model for text correction. So it means that if you provide the model with Slovak with some grammar and stylistic mistakes, our model should improve the text so that it would be readable in fluent and flawless Slovak. So here are again some examples that we can look at. First, you see the translation by LLaMA 3 model, where you can see that there are there are mistakes. If you're a Slovak native speaker, you can see that the text is not so flawless. You immediately see that there are some mistakes which make reading of the text really uncomfortable, and you immediately see that it's machine generated.
Excuse
So
me.
after
Excuse me.
6,000,
I'm
yes,
sorry for interruption. One of our attendees wrote us that we can't see the examples, so maybe there is something going wrong in your presentation. I'm not sure.
I see. I
Okay.
share the screen. You cannot see the screen. Yes,
No, we can see just your presentation materials.
well, there are examples in presentation. Right now, you see a slide with an example. Example
Okay.
after 6,000 samples. Can you see that
Yeah,
slide?
now we can see it. Yeah, yeah, thank you.
Okay. So this is an example after 6,000 samples, and after this much fine-tuning, our model was really not that good yet. You see, there are many words that are probably from Polish or from Czech or from other Slavonic language, which is a common mistake from those multilingual models that are trained on multiple languages. But after 11,000 samples, we can see that really the grammar and style is very much improved. The only mistake here, we can see that a word was translated wrongly, probably because the original word in translation was also a Czech word, so our model did not have experience with that word, and it translated only something similar in the latent space. But as for the style and as for the grammar, you can see that really the model improved and corrected the mistakes from the machine translation. So that's the work that we are doing currently, and we are still working on improving the vocabulary and provide more samples to the model so that the corrections would be of even higher quality. And of course, after this model will be fine-tuned, we will also publish it on the internet so that anyone can use it. And we hope it may be helpful either to the translators or to common people who would like to translate some text from English into Slovak and really do not see they do not wish to see the remains of machine translation. Okay, so that is the our model for correction of Slovak. Second avenue we pursued is the enrichment of Slovak corpus, of text corpus, with some scientific text, because that's one of the fields that really lack the digitized text in Slovak. What we did is we took the PLOS database, which is freely available on the internet and comprises several thousand text files, which are the scientific articles from PLOS publications. And there are about 300,000 articles of high quality scientific research. And we took the LLaMA Gemini to Flash experimental and prompted it to create summaries of those articles in Slovak. And as the process is really computationally demanding, so far we managed to publish first 10% of the database, which still is about 30,000 text files available again on the Hugging Face platform. And we hope to use these texts on training next generation of models in Slovak language, so that those models would be capable of speaking about science, about scientific concepts. And so far we found this kind of data lacking, so that's why we decided to do this. Again, here is an example of such a summary, which deals with biology, with proteins, and some biological research. And you can see that the text is really of relatively high quality. It uses correct Slovak grammar and style, and also the professional terms seem to be okay. We are not capable of checking all the translations because it's really a daunting task. But what we randomly looked at, really those texts seem to be of relatively high quality. And what is interesting, when we took a piece of this text and tried to search the Slovak internet, we really found no mention of such a research, which implies to us that really many of those texts are many of that research is not really available in Slovak. So by using it to train LLMs, we can bring Slovak users and Slovak scientific community a possibility to explore these data also in the national language. So that path of research is really promising, in that we can really bring some new content into Slovak for Slovak users. Okay, so that was our second endeavor. Now, what we are also doing now is we try to augment Slovak-specific data and train a new model on this data. The reason for this is that if you prompt those large state-of-the-art international models like DeepSeek or GPT with Slovak-specific data, and of course with data specific to any other national languages or traditions, you very often find not even mixed, but outright wrong responses from those models, which is understandable, as they focus mostly on English culture and English history, and on the facts that are really kind of international, and they probably do not have the resources, or they did not find it worth to pursue the quest for loading those models with quality data on a national culture. So correct the situation, we also are producing the augmented Slovak-specific data on language, culture, history, traditions that really cannot be found in those international models. Again, here are some examples. Okay, we asked DeepSeek model about a
I'm
poem
sorry.
by.
I'm sorry. I'm not sure if we can see the examples.
Again.
Yeah, again.
Well, again, there it's directly in my presentation.
Okay, maybe I don't know.
So you cannot see the presentation now, or can you see the example
we can,
DeepSeek V3? It's
no, we
current.
can see the slide with the name example read summary in Slovak. That's what we see, I believe.
Example, right? Okay, so it's 2 slides back. So that's really interesting because so I'll try to stop sharing and start it again. Maybe it will improve the situation. So let's do it one more time. Share the window. Okay, is it better now?
Yeah, we can now see example DeepSeek V3.
Great. So I will go on, and if again such a lag occurs, just please let me know, and I'll try to fix it. Okay, so now you can see the example DeepSeek V3, right? Great. Okay, so we asked DeepSeek about a poem by a famous Slovak poet, Miroslav Válek, and the DeepSeek had some knowledge about it, but really clearly presented a lot of wrong facts, and also presented many generic answers that can really be applied to maybe any poem, and it's also just hallucinated the verses that are not in the real poem. So again, it obviously did not have much information on the subject. And then we asked GPT 4o, and it was even worse. It was complete gibberish. So we can really see that those large models, when it comes to the specifics of national culture, are really off the mark. And what is even worse, they hallucinate, and the user may get the false impression that he or she learned something, but of course the data it presented is completely wrong. So that's why we are trying now to augment these facts, or that stack of data using Slovak resources. For example, there is a digital study room of the Slovak Academy of Sciences that provides such information, and you may see that it correctly states the poem, and also the context of this poem. And here is an example that after providing the text of the poem to DeepSeek and asking it to create a question and an answer based on this text, it provided really a specific and quite precise answer. So again, this technique gives us hope that using DeepSeek, which is the
I'm
only.
sorry
Yes,
again for interrupting. I think that the slides again
again. Oh, okay, so
are frozen.
I'll try to restart it again. It's
It moved before you restarted it, so I don't know where the problem is, but yeah.
Okay, can you see it now? DeepSeek V3 augmentation should be the correct slide.
Yeah, I can see now the black screen.
The black screen.
Yeah.
Okay, would it really? I'll try maybe to share not only a window, but the whole screen of my computer.
Yeah, now we can see example DeepSeek V3 augmentation.
Okay. Okay, so let's go on. As you can see, after we provided DeepSeek with a complete text of the poem and asked it to generate a question and answer based on this question, it really provided quite a specific and quite correct answer. And this gives us hope that using DeepSeek we can really enrich the Slovak text and to create instruction data that will allow us to train a model, to train the Instruct model that will be capable of talking and answering questions about Slovak-specific text and culture and data and as well, and all that. So we chose DeepSeek for this because it's the only really large model which is open, which is freely available, and again, thanks to the access to Leonardo, we are able to run it, even if it's really large and requires a lot of GPUs to load. So using DeepSeek, we can start creating a database of Instruct data in the Slovak language and on Slovak specifics. Okay, so that was the method of augmentation. Now, okay, so basically this was the main. These were the main areas that we are working on right now, and still there remain few other avenues worth discussing and worth pursuing. So let's look maybe at them. Okay, one question that expects us to be solved is whether to use the data for pre-training or for fine-tuning of Slovak LLMs. As you may know, both the approaches have their advantages and disadvantages. And most probable path for us will be to create one base model on Slovak using the data that we now have and that we are negotiating to acquire from different sources, and to create one base model for Slovak language, which is still lacking. So far, the most advanced model for Slovak is our Mistral 7B SK, but it is still pre-trained on the base model from Mistral. But what we are considering now is to train a fully native model in Slovak, which would give us the advantage that it would not suffer from any biases from different languages, and it would be a really good foundation for fine-tuning it on different Slovak-related tasks, either in medical research or in law, counseling, or in translations. So really, such a model could be then relatively quickly fine-tuned to any other task. And then after creating such a model, we can really fine-tune it to the instruction data on Slovak culture or Slovak traditions or Slovak science or any other problem that we may think of. And really, those fine-tuned models are performing better in niche tasks. So we hope to provide such a foundation for next generation of Slovak LLMs. So that's one question we're still facing. Other question is how much data do we actually need? So far, we trained Mistral SK on around 5 gigabytes of data, which was enough for that model. But using those techniques I mentioned, we will be able to get to amount several times more. So we are expecting to be able to train a native maybe 7B model that would be really native in Slovak. And we really have access to relatively high quality data. So the research shows that high quality data skew the ratio favorably. So we do not need that much tokens per parameter. As you may know, so the discussion on how much tokens per parameter is necessary is still ongoing, which numbers that vary really widely. But if we take about 2 tokens per parameter, that means about 14 gigabytes of Slovak data, which is quite possible to achieve. So that's another question that we are talking about. Okay, now there are 2 more research paths that we are considering, because so far we concentrated on the production of Slovak data, on the deployment of LLMs to create the basis for the digitized data in Slovak. But we are also curious about other things, like how really are the different languages represented in LLMs. There is also some research that proposes that there is kind of common semantic space in the LLM, and first layers just translate the language into kind of common universal representation, and then the final layers translate it back. But still, it's not clear how exactly those pathways in LLMs work. What is the representation of individual grammar structures? And if we really could see into it, we may be able to train the models more proficiently, and maybe even get some insights into how humans may may process the language data. So that's an interesting research focus that we may try. And there is one more research avenue, which you may have heard of. It's generally called neurosymbolic AI. So far, those LLMs are based on probability inference, which also occurs in human brain. But still, we can see that in comparison to human thinking, those LLMs have their limitations. And one major difference that we can see is that humans seem to deploy not only kind of probability inference or kind of Bayesian brain processes in their brains, but they also use rule-based or symbolic manipulation methods like mathematics or really any experience that you learn at school or at work. So this is a different area that the LLMs are not yet capable of simulating. So we are thinking about the architecture that would merge both probability inference and symbol manipulation in the way it's done in the human brain, because in the human brain we see really kind of uniform neural structure all over the brain, and still the brain areas are capable of doing really different tasks. And there is some research that really looks at so-called repurposing of neurons, that the same neurons can switch between different dynamics of processes, and are able to complete different kinds of tasks. And also that human brain is capable of creating so-called internal models of the world, that it creates kind of continuum that really doesn't need to have knowledge on all the points on that continuum, but once that model is in place, human brain can really take this model and infer the things about the world. And this is again something that the LLMs are so far missing. So these are the avenues that we are trying to pursue in our research. Okay, so as for my part, I think I covered the basics of presentation. So I would be glad to answer any of your questions, or maybe hear your comments. So if you are interested in any part of our research, I feel free to ask. Okay, so thank you for your attention.
Thank you very much for the presentation. We really appreciate it. And now I'm opening the Q&A session. So if there are any questions for the speaker, now it's time to ask them. So if not, maybe I'll start, because I have really general questions. But first one is very interesting for me. So how important is cultural representation versus grammatical correctness in evaluating large language model performance?
Okay, so I think these are actually two different metrics, let's say, which are equally important, because in order to enjoy really flawless text, you need the model to be able to follow the basic grammar and stylistic rules. So as for user experience, the correct grammar is really important. Also, if you want to produce texts that are destined for general public, you really want your text to be flawless as far the grammar goes. But the facts, of course, are equally important, because if you want to use a model to learn some new knowledge, or maybe to extract some knowledge from the existing data, of course you need the correct facts. So the both are important, but there are different fields, and you need little bit of different tools to improve both of those, to improve any of these metrics.
Okay, thank you very much. Are there any questions? Other questions? I would like to make space, of course, for you. So if you have any questions, please go ahead. Okay, I have one more practical questions. Are there any ways for the general public or non-experts to contribute to language datasets?
Well, in research, there are several ways that general public can participate. There are web portals that may show the model to the public and let the public interact with this model, and thus the new data are collected. Or there are companies that really hire people to give a human feedback on those LLMs. Again, the Slovak Academy of Sciences is trying to build a new supercomputer, Perun, and maybe it will have the capacity to create such web user interfaces, and then it may be possible to open those models to public. So that's one possibility. Another possibility is that there are some efforts now to bring the LLMs to the mobile devices. So when you quantize the model, when you really shrink the model to the size that is possible to be run on a mobile device, you can then really download the model to your mobile phone and interact with it. So that's something that we may do in the future, but so far we do not have the resources for that. But then it really would be really useful also for researchers and also for people, where you can deploy the model directly on your phone or on your PC, because you will be able to own your data. Because so far, when you chat with ChatGPT or DeepSeek Online, all that data is recorded somewhere on the cloud, and you really are not sure that the data is really yours. So once those models will be available on mobile devices, you can really share sensitive data. You can uh, really put there anything you want, and still you own the data. So that's another possibility.
Yeah, the interaction with the model would be great. I believe that people in Slovakia would appreciate it, and the model itself would benefit from it. We have another question from our new colleague. If I may, I would read it for you aloud. So the question is, do you have also direct cooperation with Mistral AI? Will Slovak model be included by default also to SageMaker AWS soon, or we will still need to download it from Hugging Face. I'm not sure if I pronounced it correctly. I'm sorry.
Okay.
So I'm sorry. Go
Yes.
ahead.
So far we are not considering including it in Mistral. We're not so far in communication with them. Again, we do not rule out such a possibility, but first we want to focus on creating the model and make it available on Hugging Face, and then maybe downsize it so that it can be run on PC. We really welcome any suggestions, but we have to consider that so far we are 3 people on our team, so we really do not have the capacity to pursue all the avenues. But yeah, that's an interesting suggestion, and maybe in the future we can do that.
Okay, thank you. So I think that there is time for one more question. If anyone has question for Dr. Dobeš, please go ahead. If not, I have one more question, last question. I would like to ask you if you could share with us the presentation slides after the session. I think that
Sure.
all, yeah, great. That's great. Thank you very much. So thank you, Dr. Dobeš, for very interesting presentation and for showing us great result you and your colleagues have achieved. And thank you all for joining us today. And great day. I wish you a great day. Thank you.
Thank you very much for your attention. Thank you that we could have such a discussion and such presentation, and yeah, have a nice day.